Hi, Mrs. McTaggart here, and in this video we are looking at the higher maths topic of compound angle formula. And in more detail, that means we're going to be looking at expanding and simplifying expressions for sine bracket a plus or minus b and cos bracket a plus or minus b. So before we go into this video, I just want to remind you of your exact values because they play a huge part in this topic. So remember, I teach exact values coming from the triangles. Other people teach you just to memorise them. So the two exact value triangles you have is an isosceles triangle of sides 1 and 1. Using Pythagoras, the third side is root 2, and that would make this angle in here of 45. So from that, you can get your opposite, hypotenuse and adjacent, and you can get your sin, cos and tan of 45. The second triangle is your equilateral triangle of sides 2, which you then split down the middle. So if you split that down the middle, you have a right angled triangle and you have 1 on the bottom. So using Pythagoras, you've got 1, 2 and root 3 for the height. And then that makes this angle of 60 and this angle of 30. And again, depending whether you're using 30 or 60, you would use sin, cos and tan to get the other ones. So you need to either memorise the triangles or just memorise all your exact values off by heart. That's what I'll be using when I'm doing this. And I will just be, when I get my answers, I will just be saying, so sine 30 is, sine 60 is, and it's up to you to know that this is where I'm getting them from knowing my triangles. So what we have here is, the bit in pink is a formula, and this is given to you in your formula sheet. You don't need to memorise it. You just have to be able to look up your formula sheet and copy it down correctly, or adapt it to match what we've got. So they're asking us to expand sine bracket x plus 60. Now you can't just do what you normally do in brackets and multiply out. You can't say that's sine x plus sine 60. That is not mathematically possible. We have to use this expansion up here. So what has happened here is basically my a has been replaced with an x and my b has replaced with a 60. So I'm going to write out the bit in pink, but I'm replacing a with x and b with 60. So this is simply sine x cos 60. Now it says plus or minus in here. If it was a plus in your bracket, it stays a plus when you expand it. So plus, and then it would be cos of my first term, so cos x, and sine of my b second term, which is 60. Now what we do is we actually replace cos 60 and sine 60 with their exact values. So cos 60 is a half, so we're going to put that at the front. So this is a half sine x for the first term. And sine of 60 is root 3 over 2, so put that to the front. So it's root 3 over 2 cos x. And I can't do anything else with this just now. Later on we'll teach a topic called the wave function, and this is part of that really. So that's that question done. Question 2 says find the exact value of sine 15. So what I need you to think of is sine 15 as either sine 60 minus 45 or sine 45 minus 30. Whichever expansion here I use will give me what sine 15 is. And because I've already used the one with the 60, I'll probably go use the one with the 45 and the 30s. So sine 15 can be written as sine 45 minus sine 30. So I said that wrong. It's sine bracket 45 minus 30. So my a value gets replaced with 45, my b gets replaced with 30. So I have sine 45 cos 30. It's a minus in the bracket, so it stays a minus. And then I have cos 45 sine 30. Right, sine 45 is 1 over root 2. So is cos 45. They both match. Cos of 30 is root 3 over 2. And because these are stuck together, we are multiplying. And sine of 30 is 1/2. Now you should notice when you're doing these is the denominators should always match when you're going to work them out. So both my denominators here give me 2 root 2. And on the top it's simply multiplying them. So in the first one I've just got root 3, and on the second I've got 1 times 1 is 1. And because my denominators match, we just put them together. So you've got root 3 take away 1 all over 2 root 2. And that cannot be further simplified. And if you wanted to go test it with the 60 and 45, you will come out with the exact same answer as that one. Okay? Like the third scenario of questions are ones that come up on quite a lot in the exams, and people tend to kind of forget them a wee bit and don't know where to start. So I've started my question off by saying sketch triangles where. In an exam it'll just say cos A equals 4/5, find sine of A, or find tan of A. And to be able to do that, I think about a little triangle. So I'm going to draw two little right angle triangles. I'm going to call this one angle A, and I'm going to call this one angle B. Now I need you to cast your minds back to simple SOHCAHTOA. The formula for cos is adjacent over hypotenuse. So in my A triangle, my adjacent will have the number 4, and my hypotenuse will have the number 5. And with tan is TOA, so that would be O over A. So my opposite for triangle B would be 5, and my adjacent would be 12. Now how do I get these third sides? Well, it's basic Pythagoras. For the first triangle, you should hopefully recognise that's your classic 3, 4, 5 triangle. And for the second one, you'll do 5 squared plus 12 squared, which is 169. Square root of that gives you 13. Okay, I didn't need to do any work in there because I know these ones off by heart. You can always go do a wee bit of Pythagoras at the side. So that's part A, just want you to do those triangles. And from there, I can now read off sin, cos and tan of A and B. Right, part B wants us to expand sin A plus B. So sin A plus B becomes, this is just your original formula, so sin A cos B plus cos A sin B. And then what we do is we'll go to our triangles, and our first triangle, well, that's the opposite adjacent hypotenuse. Second triangle, opposite adjacent hypotenuse. So you just need to remember your SOHCAHTOA for these. So sin A would be O over H, so 3/5. Cos B in the B triangle would be A over H, so 12/13. Cos of A would be A over H from your first triangle, so 4/5. And sin of B would be O over H in your second triangle, so 5/13. And again, look at these denominators, they're matching, we've both got 5s and 13s. So then we can just put these together. So 3 times 12 is 36, 5 times 13 is 65, plus 4 times 5 is 20, and 5 times 13 is 65. So combined you have 56/65. And that's us, we can't do anything else with that. We're done. Okay, so what we're going to do now is we're going to look at the cos expansion. Now cos expansion is ever so slightly different. It goes in the order cos, cos, sin, sin. And also I want you to look at the signs in between. The signs have changed. So on the first, in the bracket, you've got you've got plus or minus, but when you expand it, you've got minus or plus. So basically, if it was a plus in your bracket, it becomes a minus in the expansion, and vice versa. Okay, so note the signs change on this one. It's really easy to mix these ones up. So first two examples, we're going to expand and simplify. So we are replacing A with your x and B with your 30. So this would be cos cos, so cos x cos 30. The minus turns into a plus, so it's plus, and then it's sin x sin 30. I definitely think this one's a wee bit easier to expand because it's just always cos cos sin sin, x 30 x 30. Right, we know our exact values are for cos 30 is √3/2. So you've got √3/2 cos x plus sin 30 is a half. So half sin x. Can't do anything else with that. Okay, for our second one, we're doing a wee bit of radians. So remember, pi/2 is 90. So we have cos cos. So cos x cos 90. I'm just going to leave it as pi/2 though. It's a plus in the bracket, so that becomes a minus in your expansion. I just don't quite have enough room for this one. So it'll become minus sin sin. So sin x sin pi/2. Right, for this one you need to use your cos and sin graphs. So cos of 90, so there's your cos graph. Remember this is 180 and this is 90 here. So 90 is 0. So cos 90 is just 0, so you've got 0 cos x. But technically you don't need to write that, do you? You shouldn't have to write 0 cos x, so we'll just take that away. So the first bit is 0. And for sin of 90, here's your sin graph. So this is 180 in the middle. So 90 is here, which is 1. So sin of 90 is 1. So you've got negative 1 sine x, or just negative sine x for that one. So remember, if one of them is 0, that whole kind of side drops. Okay, so you might have to go use your sine and cos graphs as well. You might also be asked to find things like cos of 120, which we'll be using your method for getting angles larger than 90. I just haven't done any of those examples in my, on this video. Okay, so for my second course one, I'm going to do ones from the triangles again. So I've got two triangles labelled V and W, and I've got two sides on them, so I need to get the missing sides. So for the first one, you'll need to do a bit of Pythagoras. You'll need to do 25 squared minus 7 squared, which gives you 576, and the square root of 576 is 24. So this missing side here is 24. And the second one is your classic 3, 4, 5 triangle again. Okay, we like that one. So we're going to do the two expansions. We're going to do the cos with the plus and cos with the minus. So cos with the plus would be cos V, cos W, minus, remember the sign changes, why have I written cos again, sorry, minus sine V, sine W. And the cos expansion with the minus would just be the exact same as what I've written over there, but with a plus sign in the middle. So there's my two expansions. Right, let's get some numbers in then. So cos of V would be, remember this is your opposite adjacent hypotenuse, opposite adjacent hypotenuse. So cos of V would be 24 over 25. Cos of W would be 4 over 5. And we'd be taking away sine of V is 7 over 25. Times sine of W is 3 over 5. Now if you do them, multiplying would give you 96 over 125 minus 21 over 125. And when you take them away, you get 75 over 125. And that simplifies down using multiples of 25 to 3/5. Now to do the other expansion is the exact same working as over here, but it's going to have a plus in the middle. So I'm just going to go skip a line, and I know that it's going to be 96 plus 21 over 125, which gives me 117 over 125. And that would be that one. Okay, that's all. And one last one, prove that cos 90 minus p is the same as sine p. Well, that would be very like the one I did with the radians in the previous kind of wee bit of lesson. So our expansion would be cos cos, so cos 90 cos p. It becomes a plus in the middle, sine 90 sine p. Cos of 90 from our cos graph was 0, so this first bit is just 0. And sine of 90 from your sine graph was 1, so you have 1 sine p. So it's just sine p, and that's all it is. That's the proof. So hopefully you followed these okay. So let me do one more example like that last one, okay? No, I tell a lie, I've got one more example to do. Find the exact value of cos A minus B if tan A is this and sine B is this. So this is using your triangles again, so let's sketch out two triangles. So we've got an A triangle and we've got a B triangle. So tan is opposite over adjacent, so our opposite is 9, our adjacent is 12. For sine, our opposite is 4 and our hypotenuse is root 32. So using a bit of Pythagoras here, for the A triangle, you've got 9 squared plus 12 squared, which is 225. And when you square root 225, you get 15. On my second one, it would be root 32 all squared. Take away 4 squared, which is just 32 take away 16, which is 16. Square root of 16 would be 4, so this is actually an isosceles triangle. Then if we find cos A minus B, that would be cos cos. So cos A cos B. Minus turns into plus, and then sine A sine B. And let's put some numbers in. So cos A would be 12 over 15, using adjacent and hypotenuse. cos B would be adjacent over hypotenuse. So 4 over root 32. Plus sine A would be 9 over 15. I'm just writing sine again. Would be 9 over 15 times sine B, which is 4 over root 32. Create a wee bit more space. So then we're just ready to multiply now. So you've got 48 over 15 root 32 plus 36 over 15 root 32. 14 add 36 is 84. Make it look more like an 8. So 84 over 15 root 32. And there's nothing that 84 and 15 divide by, so it can't simplify down. It could be that maybe they would cancel, but not today. And that's me done. Hopefully you followed these okay. Generally these are quite nice as long as you remember to look at your formula sheets and put things in the right orders. And they're only easy if you know your exact values. Thanks for watching. Bye.